First type of problem is called a difference of two squares. If you want to shorten that to dots problem, if that makes more sense to you. The key is that you're going to have two perfect squares, and what does that word difference mean? Difference means they have to be being subtracting. You have to see subtraction here. So it's the subtraction of two perfect squares. My rule is, and you're going to hear me say this a couple times today, is a difference of two squares will factor to two factors with different signs. A difference of two squares factors to two factors with different signs. Do you see the play on words there? Mm-hmm. Difference of two squares, two factors, different signs. So how do we know, first off, that it's a difference of two squares? When you look at it, you're going to see those special numbers. Do we see a number 1? We see the special numbers. Mm-hmm. We see an x squared, which is special, and we see a 16. You can break those down by taking the square root. We take the square root of each of those numbers. What's the square root of x squared? Okay. The minus sign is going to stay for the first factor. What's the square root of 16? But then these always, if you look at the actual a squared minus b squared up there, these always factor to a factor with a minus sign, and then the same factor just with a plus sign. Because if you look at that, if I were to FOIL that back together real quick, I'm not going to write it all out, but if I FOIL it back together, x times x is x squared. But then if I FOIL the x in the positive 4, I get 4x. If I FOIL the x in the minus 4, I get minus 4x. What's going to happen with those? They cancel, which is why there's no middle term here. That's the opposite signs. That's why they have to be opposite sides. That's how you get it to cancel. And then minus 16. So that's your answer. That's all you have to do for that one. So if you look at number 2, what's going to happen to 49? 7 minus, what's going to happen to 9x squared? 3x. That's my first factor. It's not just one factor. It's always two factors. The other factor, same numbers, different sign. Because it factors to two factors that have different signs. A difference of two squares factors to two factors with different signs. Good so far? When you look at number 3, those are not special numbers. Then what? I just can't factor it? What was the first type of factoring we talked about? Greatest common factor. I'm pretty sure those have one. So if you notice in your homework that you're like, oh, I'm stuck, I don't know what to do, you're probably supposed to take out a greatest common factor. We're going to do greatest common factor first here. So I'm going to take out the 2. If I take out the 2, I'd be left with x squared minus. Look it, I like that number. I like 25. That's a special number. I can factor that inside part now, can't I? I'm factoring that inside part. The 2 is just going to hang out. What does that inside part factor to? X minus 5 is the first factor, and the second factor is x plus 5, because I have to use different signs. Difference of two squares, two factors, different signs. All right, what's going to happen in number 4?
So it'll be 10x squared.
The 10x to the 4th reduces down to 10x squared. So it's going to divide the exponent by 2 when it's a different exponent. Minus square root of 169. If you didn't know it, you can take the square root on your calculator if that's not one you know. That's the first factor. The second factor? 10x squared plus 13. Remember, these difference of two squares has to have two factors with different signs. It's not just one. You can't just take the square root and be done. It wouldn't go back. We're creating two things that would take us back to that original problem. What about 5? Careful. There's something different about 5. If I write 3x plus 9 times 3x minus 9.
That's so true.
What happens when you FOIL? What happens when you FOIL at the end there?
It becomes a negative.
You're going to get negative 81. Does that say negative 81?
No. So both of them have to be positive and negative.
So this has to be, what did I say that this only works with? When it's a difference of two squares. Is that a difference of two squares?
No.
This is not a difference. So you can't factor it using this shortcut method. Not a difference. I can't factor it using the shortcut method. All I can do, there is one thing I can do. I can take out the greatest common factor. So greatest common factor only, that's all I'm going to be able to do. What's the greatest common factor?
9.
Take out the 9, I'd be left with x squared plus 9. That still looks like you can factor it, but you can't because it's a plus sign. Only a minus sign cancels. Only a minus sign factors. Plus signs won't factor. Has to be a difference of two squares. Last one. Try number 6 for a minute on your own.
So you don't.
So you should be taking out a 2 first to make these numbers that are from our list. We get 121 minus 36, x to the 4th. And then I can factor that thing inside, can't I? Those are now numbers from our list. What's going to happen to 121? Comes 11 minus 6x squared, good. And then my other factor? 11 plus 6x squared. And again, the whole idea here is if I put those back together, I'm going to get the 121, the middle stuff's going to cancel, and then I'm going to get the negative 36x to the 4th. Like you should be able to look at it and see that that goes back together. This is the other type of special case. If you look at these, if you look at the end numbers specifically, do you see our perfect squares still in those first 2 examples? But what's different about these? There's a middle term, right? There's 3 terms. So these are what are called perfect square trinomials, and these are actually super important in math. They are used in a lot of your future math classes. You will see these. So there are 3 of them. So these factor differently when they're 3. If you actually look at my note up here, they factor to something with a squared at the end of it. So I'm going to walk you through the first one and explain to you why that's the answer and how I'm going to try and show you how it works. But this is what you do. You're still going to take the square root. The rule is you take the square root of that first term, just like we did with the last one. That's going to be 3x. The sign that you want to use is always the sign of the middle term. You're going to bring that down. The sign is going to be plus. And then you take the square root of the last term, 5. And the way these work is that this is that squared. Do we know what that means when I say that it's that squared? What does that mean? There's 2 3x plus 5s. Instead of writing them both separately, we can say just squared, and it puts them together. So I want to show you, I want to verify for you just for this first one. You don't have to do this on your homework. But I want to show you, prove to you that that really does work. That means there's 2 of them. Watch what happens if I FOIL those together. I get 9x squared for the first. Outside is 15x. Inside is 15x. And the last is 25. Do you notice because they're the same signs, the middle doesn't cancel this time? The middle stays. What happens to the middle? They add together, and you get 30x, don't you? Wouldn't that be what the answer was supposed to, what the original problem was? So really easy way to check this. So you don't have to do this each time. I don't really want you to write all this work out each time. Really easy way to check it, because a lot of you are going to look at the 30 and say, but I didn't do anything with the 30. How does the 30 here? Really easy way to check it is you're going to do the 3x times the 5 times that 2 that's on the outside. If I multiply those, that's how you can check to make sure that middle number is still going to stay there. So if I check that and I do 3x times 5 times the 2, what does that make? That makes 30x, doesn't it? That checks the middle term for you. That checks the middle term to make sure that it stays. So let's do the next one. These should be easy, but I'm trying to prove to you mathematically that they really do work. You don't have to do the proving part when you do your homework. They should be real easy when you do your homework. What am I going to do the first? Square root of that is 4x. The sign here is where you got to be careful. That's the one thing we take from the middle term, the middle term. That's going to be a minus sign. And then I skip to the end. The other perfect square number was the square root of 49. 7. And then make sure you put that squared outside, because having that squared outside is going to help you to check now to make sure that that really does work. 4 times negative 7 times 2. 4x times negative 7 times 2. What do I get? Don't I get negative 56x? That negative 56x is really still part of the problem. You just don't see it when you write it down. When you FOIL it together, it would pop back up. Yes?
So we don't have to check it, right?
You don't have to check it. I mean, it's a nice thing to do to make sure that it is technically a perfect square. All right, let's look at the next one. Are those numbers? So what are you going to do? You got to take something out first. Greatest common factor first. What can you take out? I can take out a 2. Because look at what happens to that first number. Think about what happens to that first number when you take out 2. What does it become?
9.
I like 9, don't I? So you're really trying to think of something they have in common that would make a number that's from the list. So this is 9x squared plus, that's going to be 42x plus 49. I like that number too. So when you look at a problem and you see that these are both perfect squares, you know you can use this method. 2 hangs out front. What's going to happen to 9x squared? Take the square root, it's 3x. What sign am I going to have? I'm going to have the plus sign, and then what's going to happen to 49? 7. And what do I have to remember at the end for these? You got to remember the squared. If you don't put the squared, you're never going to get back to that original problem. Your goal is always that when you put it back together, you're going to get the original problem. And if I do my quick check right now, you should be able to just mental check this. 3x times 7 times 2. That's 21 times 2. Isn't that 42x? It matches that 42 we had in the middle. You're always checking it with that last problem, not the original problem, but the first step you made after the greatest common factor. Do number 4 on your own. So here we go. First step was to take out the 5x. You should be left with something that we like here. We get 4x squared. I like that. That's a good number. Minus 12x. Plus, that turns into 9. I like those 2 end numbers. Those are the ones we're focused on right now. We want those 2 end numbers to be perfect squares. The middle one will never be a perfect square, so don't worry about the middle. It's the end. So then you have 5x times, take the square root, 2x, take the sign. That's the one mistake I was catching on a couple people. So you have to take the sign of the middle term. That's the one thing you take from the middle term. Square the last term, 3 squared. That's your answer. If you check it, if I do the 2x times the negative 3 times that squared, that's why that squared is important. It helps you to make sure that you write that too. If you do the check and you forgot to write the squared, you'll remember to write the squared. Don't I get negative 12x? Which is what that middle term is. Check. It works. Questions?